Today, we re-diving deep into the science, history, and wonder of transits and oppositions, the unsung celestial events that changed astronomy forever. Let us start with the basics. What exactly is a transit? A transit happens when a smaller celestial body passes directly between a larger one and an observer. In our solar system, the most famous transits are when Mercury or Venus moves across the face of the Sun as seen from Earth. Imagine holding a small coin up to a bright light bulb. When the coin lines up perfectly between your eye and the bulb, it casts a tiny dark shadow on the light's surface. That's a transit in simple terms. But on a cosmic scale, this tiny shadow is one of the most powerful tools astronomers have ever had. Unlike eclipses, which block most or all of a star's light, a transit only blocks a tiny fraction of the sun's light, making it a subtle but incredibly meaningful event. The history of observing transits is one of the greatest stories in science. For most of human history, people saw Mercury and Venus transits as rare, mysterious signs from the heavens. Ancient civilizations tracked these events, but couldn't explain them. They saw them as omens or divine messages, not as predictable orbital movements. It wasn't until the 17th century, when Johannes Kepler published his laws of planetary motion, that astronomers realized transits were not random. Kepler himself calculated that a Mercury transit would happen in 1631, and sure enough, astronomers across Europe witnessed it. This was the first time humanity proved that planetary movements followed strict mathematical rules, breaking free from ancient myths and superstitions. But the real game changer was the Venus transit. In the 18th century, scientists knew that if they could measure a Venus transit from different points on Earth, they could calculate the astronomical unit, the distance between the Earth and the Sunday. This was the single most important measurement in astronomy at the time because it let us scale the entire solar system. So governments sent teams of astronomers to the far corners of the globe, to Siberia, to Tahiti, to South Africa, and to remote islands in the Pacific Ocean. Many faced dangerous journeys, harsh weather, and even war to make these observations. Some died before they could record the data, but those who succeeded gave humanity its first accurate measurement of the solar system's size. Before the Venus transit, we had only rough guesses. After it, we knew the exact distance to the Sun, to Mars, to Jupiter, and every other planet. That's the power of a simple transit. It turned guesswork into fact. Today, transits are no longer just a tool for measuring our solar system. They how we find exoplanets, planets orbiting stars outside our Sunday. NASA's Kepler Space Telescope and TESS mission use the transit method to hunt for alien worlds. When a planet passes in front of its host star, it dips the star's brightness by a tiny amount. By measuring that dip, astronomers can find the planet's size, orbit, and even clues about its atmosphere. Thousands of exoplanets have been discovered this way, from rocky Earth-like worlds to giant gas giants bigger than Jupiter. Without transits, we would know almost nothing about the billions of planets in our galaxy. It is a testament to how a simple cosmic event can unlock the secrets of the entire universe. Now, let us turn to the other great celestial event, opposition. If a transit is a planet passing between the Sun and Earth, opposition is the exact opposite. Opposition happens when a planet is on the opposite side of Earth from the Sunday. So the Sun, Earth, and the outer planet line up in a straight line, with Earth sitting in the middle. For observers on Earth, this means the planet rises as the sun sets, stays visible all night long, and appears at its biggest and brightest. It is the single best time to view Mars, Jupiter, Saturn, Uranus, and Neptune planets that orbit the Sun beyond Earth's path. Think about Mars opposition. Every 26 months, Mars reaches opposition, and it turns into a brilliant red point of light in the sky. Telescopes can pick out its polar ice caps, deserts, and canyons in stunning detail. NASA uses Mars oppositions to launch missions to the red planet because the distance between Earth and Mars is at its shortest. The Perseverance rover, Curiosity, and even the historic Apollo-era missions all timed their launches around Mars oppositions to save fuel and travel time. Without opposition, human missions to Mars would be far harder, slower, and more expensive. It is a cosmic alignment that makes space exploration possible. Jupiter and Saturn oppositions are just as spectacular. Jupiter, the largest planet in our solar system, shines so brightly during opposition that it outshines every star in the sky. Amateur astronomers can see its 4 largest moons, Io, Europa, Ganymede, Callisto, moving around it night after night, like a mini solar system. Saturn's rings become crystal clear during opposition, showing off their intricate gaps and icy bands. These events don't just look beautiful. They give astronomers a chance to study weather patterns, storm systems, and magnetic fields on these giant planets. The James Webb Space Telescope often targets planets during opposition to capture the clearest possible images and data because the planet is fully illuminated by the sun and closest to Earth. What makes both transits and oppositions so special is that they are 100% predictable. Astronomers can calculate transits and oppositions hundreds, even thousands of years into the future. We know the next Mercury transit is in 2032, the next Venus transit in 2117, and the next Mars opposition in 2027. This predictability is what makes them such valuable tools for science. They are not rare accidents, they are proof that the universe follows consistent, understandable rules. For ancient astronomers, this was a revelation. For modern scientists, it has a foundation for every discovery we make. It is easy to take these events for granted, especially when we have powerful telescopes and space probes exploring the solar system. But we should never forget that transits and oppositions taught us how the universe works. They taught us that Earth is not the center of everything, that planets orbit the sun in fixed paths, and that we can measure the vastness of space with simple observations. They turned astronomy from a philosophical pursuit into a hard science. They let us find exoplanets, plan space missions, and understand our place in the cosmos. When you watch a transit or an opposition, you not just looking at a planet moving across the sky, you witnessing the laws of physics in action. You part of a long line of humans who have looked up and wondered, who have used these events to push the boundaries of knowledge. Every time a Mercury transit crosses the sun, every time Mars shines brightest at opposition, we reconnecting with the past and reaching for the future. The universe is full of amazing phenomena, from black holes to nebulae to supernovae. But transits and oppositions are the quiet heroes of astronomy. They are accessible to anyone with a pair of binoculars or a small telescope. They are rooted in simple physics, and they've changed the course of human understanding. They remind us that you don't need a giant space telescope to explore the universe. Sometimes, all you need is to look up at the right time and watch the cosmic dance unfold. As we continue to explore, space transits will keep helping us find new exoplanets, and oppositions will keep giving us the best views of our planetary neighbors. NASA and other space agencies will keep using these events to plan missions, collect data, and make new discoveries. And for ordinary people, like you and me, they'll keep offering a chance to see the universe as beauty with our own eyes. So the next time you hear about a planetary transit or opposition, take a moment to step outside and look up. You'll be witnessing an event that has inspired scientists, explorers, and dreamers for centuries. You'll be part of the endless human journey to understand the cosmos. The universe is always speaking to us. We just have to know when to listen and when to watch for its most perfect alignments. Please like, comment, share, and subscribe to the channel.